Hi, and welcome to a brand new video. So today we're going to be tackling the problem on the screen where basically we have a binary tree and we're going to split it at one point in the tree. And this point is going to be when the sum of the subtree that we got to times the sum of the other subtrees are equal are the product is basically the maximum out of all of the possible combinations. So in order to tackle this problem, what we're going to do, just quickly before you do that, you can kind of see here that for 11, I know it's a little bit hard with just a list, but we can split it here, so the sum is 10, and we can split here, so the sum's 11. Together, that is the max of 110. So to solve this problem, you might actually think that we need lots of methods, but in fact, you only need these two that I created here. And this is the default one, and this is one that I created. So you might think that, hey, what you need to do in order to solve this problem is the first step is to calculate the total sum of all the nodes. And yeah, that is the first step. Then you might think that, hey, the second step is to iterate through the nodes and find the part sum find uh, and find like the part sum, so sum of the subtree. So I'll do that. Find the sum of the subtree. And then lastly, you will find the maximum of all the sum of subtrees. However, though this is the basic plan that we are doing, we don't need three methods in order to do that. So what we're actually going to do is we're going to use a method to calculate the total sum, but we're going to store the running sum of the subtrees in a list because technically we're just recalculating that if we do uh, another method. So we'll store sum of subtree in a list so that we can essentially skip this step 2. And I don't know how to cross it out, so I'll just do it like this. And then that's how we can find the maximum of the product. So let's get started. So if the first thing we need to do is the base case. So if root equals null, we just want to turn 0 because that means that um, it's not worth our time. And it's going to probably cause an error. So next what we're going to do is I'm just going to create a global variable, private list integer list, and this list is going to keep track of the running subtree sums. So I'm just, oh, whoops. I'm just going to set this dot list to new array list. And then I'm going to say that the total sum, and to solve this problem, I'm just going to use long just because with bigger trees and bigger numbers, then soon it will become really big. So long is better than int. So long total sum is equal to total sum of root. So we'll code this method in just a bit, but once we calculate the total sum, then we will this list will have all the subtree sums, right? So let's code this method. So here I'm just going to create a variable sum, and that's going to be root.val. If root.left is not equal to null, we want sum to plus equal total sum of root.left. And we're going to do the same thing with root.right. So what this is doing is and now it's taking the total sum of the current node and the subtree left and subtree right. So now that we have the sum of the subtree, we can do list.add sum, to the running list of um, subtree sums, and then we can just return sum. So that now we will be able to calculate all of the subtree sums while also calculating the total sum. So two jobs done in one method. And then now that we do have this list of subtree sums, we can do for long sum in the list. And actually you don't need these because it's only one line. We're gonna create a new variable, answer, and we're gonna say this variable is equal to maths.max of and um, total sum. Oh, let me create a parenthesis. Total sum minus sum times sum. And this is how you calculate the product, right? So you take the total sum, because it's the sum of the subtree times the sum of any times the sum of everything else, right? So you can just do this. You don't need to recalculate like the other one. All you need to do is take the total sum and minus sum. And then lastly, we're just going to return int of ands divided by math.pow 10 to the 9 plus 7. And the reason I'm doing this is so that if it's a really big number, this is just normally a good number to do the module of. So just kind of reiterating through the steps that we did in order to solve this problem, we first created a method, and this calculates both the total sum and the sum of all the subtrees at once by storing it in a list. And then we can iterate through this list and find the maximum product of the subtree product, which is, if you remember from the problem, return the maximum product of the sum of two subtrees. Since the answer may be too large, return at module 10. This is supposed to say to the 9 plus 7. So that's why I did that here. And just return that maximum product. So I hope this video was helpful, and see you in the next video.